Let's talk about the process of finding the inverse of a matrix. Particularly in this video, we are going to focus more on 2 by 2 matrices, while in the upcoming video, we will consider 3 by 3 matrices. So let's begin with the first one. If matrix A to be equals to the following elements 2, 1, 5, 3. How can we find A to the power of -1, which is the symbol we use to represent A inverse or the inverse of a matrix? Well, there's a formula that helps us to do that, but let me just write it at the top right hand corner over here. If A is a matrix and it consists of elements W, X, Y, and Z, its inverse will simply be equals to the reciprocal of the magnitude of A, which is simply the determinant of matrix A, then multiply by the change in position of elements in the leading diagonal of matrix A. So you switch Z to the position of W and you switch W to the position of Z. Then you negate the other element, minus Y, minus X. And this will be your inverse. That is something you want to keep in mind. So if that is the case, let's apply this to this problem. So A inverse will be 1 over the determinant of A. Then multiply by, let's switch 2 and 3, typically their position. Then we are going to negate 1 and 5. So that's going to be -5, -1. So our main goal right now is to determine the magnitude of A, which is the determinant of matrix A. To determine the determinant of matrix A, multiply the leading diagonal, typically the elements, and subtract it from the product of the second diagonal. So 2 times 3 minus 5 times 1. So what would that be? Let's do the math. 2 times 3 is 6 minus 5. So the determinant is simply 1. So at the end of the day, the inverse of matrix A will be equals to 1 by 1 multiplied by 3 minus 1 minus 5 and 2. And final answer is 3 minus 1 minus 5 and 2. And this is the simple way and quick way to determine the inverse of a matrix. Example 2. Consider a matrix B to have the following elements: -5, -4, -2, and 0. How can we determine B inverse? So just like before, we know that B inverse will be nothing but the reciprocal of its determinant multiplied by the change in position of the elements in the leading diagonal. Then we are going to negate the element in the second diagonal, since the elements in the second diagonals are full of negative values. Negating them will result in positive values. Minus times -4 is +4. Minus times -2 is +2. So now let's compute the determinants. So -5 multiplied by 0, that's 0, minus -2 multiplied by -4. That will result in +8. And at the end of the day, the determinant of B is -8. So now it's easy for us to determine its inverse. So that's going to be 1 over -8 multiplied by 0, 4, 2, and -5. In some cases, depending on your lecturer or teacher, answers might be left this way, but sometimes you might be required to distribute. But in most cases, you will need to distribute, so I will recommend distributing. So let's distribute -1/2 to each of the elements present in this matrix. So therefore, final answer of B inverse will be 0 times -1/8, that's 0. So this should reduce this to 1 by 4, -1 over 2. Then this will be -1 over 4, and we have +5 over 8. I hope you understand how I did that. That is simple math operations. Hopefully you find this helpful, and I believe by now you should be able to find the inverse of a 2 by 2 matrix. Here is an exercise I have for you. So consider matrix C to be equals to -5, 3, -1, and 4. Feel free to find the inverse of this matrix and let me know your solution in the comment section below. Thanks for watching. See you guys in the next video. Bye for now.